In Lesson 3.4, you learned how to create multiple threads to speed up complex tasks. But the code you added introduced something called a race condition. In this lesson, you'll learn about race conditions and fix the code to prevent one from occurring. To begin, open the Mathland project from your sample files folder. And view primes.aspx in debug mode. To do this, first open primes.aspx and then click Debug. Start debugging. Now you'll see the race condition problem. Enter 100 into the maximum value box and click Calculate Primes. The calculation may work without any problems. Note that you may also find that no results are returned. This is also related to the race condition problem. Now enter 100,000 into the maximum value box and click Calculate Primes. This time, an exception occurs, and you are returned to Visual Studio. Note that race conditions are notoriously unstable, so it's possible that the code won't behave in exactly the same way on your computer. If you continue to click Calculate Primes, the error should eventually appear. But don't worry if it doesn't. All that's important is that you recognize that this code is not working correctly. To understand why this error occurs, consider what is happening in the code. First, thread 1 begins, and, while it is still running in the background, thread 2 begins. Without waiting for thread 1 and thread 2 to finish, the code then immediately attempts to populate the listbox control with the results, even though the results are not complete. When you calculated only 100 numbers, thread 1 and thread 2 managed to finish very quickly, so the results were already complete before the code populated the listbox control. This problem is called a race condition because everything works perfectly if thread 1 and thread 2 win the race. They must finish before the code tries to display the results, in order for the code to work. Clearly, it is necessary to wait until thread 1 and thread 2 are finished before populating the listbox control. You'll do this now to correct the error. Stop debugging now and add the following code after the line that begins thread2.start. While thread 1 dot is alive, or thread 2 dot is alive, thread dot sleep 1000. This while loop will cycle as long as the thread 1 and thread 2 objects are both alive. That is, as long as they are both still running their calculations. Thread.sleep tells your application's main thread to wait for a number of milliseconds before continuing. Without the thread.sleep line, this while loop would cycle as fast as your computer could manage, which would be a waste of your computer's processing capacity. By adding this line of code, the while loop will only check whether the threads have finished once every second. Now let's test your new code. View primes.aspx in your web browser. And click Calculate Primes. This time, the calculation runs without any problems at all. Your code correctly waits for both threads to finish before binding the numbers to the listbox control. The calculation also finished in just 18 seconds this time. It took 23 seconds when working with a single thread in Lesson 3.4. This may not seem like a huge performance increase, but the difference would be a lot larger if you were to calculate prime numbers up to 1 million, for example. The calculations finished faster because they were shared between the processors on my computer. If your computer only contains a single processor, you might not see any performance increase, as your computer has to handle both tasks on the same processor. Close your web browser now, and close Visual Studio. You've now completed Lesson 3.5. Prevent race conditions when working with threads.